We are starting Chapter 8 today. We are doing 8.1, which is multiplying and dividing rational expressions. So if you remember, rational refers to fractions. So what we're doing today is we're multiplying and dividing fractional things where there's a polynomial on both the top and the denominator. And to simplify into both the rational and the complex ones, we're going to be using factoring techniques. So we are going to go back to using some factoring things. But first, let's talk about what a rational expression is. It is a ratio of polynomial expressions containing polynomials in the numerator and the denominator. So as we look at this, we are looking at noticing that there are variables in both the top and the bottom. And so in that denominator and the numerator, there's going to be something involving x. And typically it's going to be monomials on both of those accounts. Or, excuse me, polynomials, not monomials. But it might be monomials sometimes. So we're going to take a look at how to simplify these, and then, meanwhile, multiplying and dividing them. So first off, they just want us to simplify 2x times x minus 5 all over x minus 5 times x squared minus 1. To simplify this, remember, in order for us to cancel both the top and the bottom, we have to have the exact same thing, and it has to be able to multiply. So notice we have this is multiplied by this, and this is multiplied by this. There's no addition or subtraction except inside these things. Well, I can cancel this whole term with this whole phrase. So those two cancel, and I'm left with 2x over x squared minus 1. Now that does factor, but it's not going to factor so that it helps me reduce this anymore. That's as far as I can go. And recall, you cannot cancel these. X and x squared do not cancel because this is being subtracted from. And so this is as simple as this one will get. Now their second question says, under what conditions is this expression undefined? Remember, where is it undefined? When the denominator equals 0. Well, that's not a sufficient answer because they're asking us what are the conditions. Well, when does this equal 0? So I'm going to set that equal to 0 and we're going to solve it. I say x squared minus 1. Whatever's in the denominator, you set it equal to 0. So we have x squared is equal to 1. Take the square root. X is equal to both plus and minus 1. So when x is plus and minus 1, this whole thing is undefined. Let's continue to simplify some of these. So now they're not factored for us already. We have to factor them to figure out what can I reduce and simplify. They don't ask us about discontinuities, so we don't have to answer that question every time. So how do I factor z squared w minus z squared? Well, I can factor out that z squared and just make it w minus 1. Divided by, what factors out here? Z cubed will factor out of both of these. And it's become 1 minus w. We just did a whole section on this, so we can simplify these things. Z squared over z cubed, these reduce, and we're just left with a z in the denominator. Now, some of you might be tempted to cancel this. It's not the same. W minus 1 is not the same as 1 minus w, but we can make it the same. If I were to factor out a negative 1 from this, so if I multiplied it by a negative 1, it's going to rewrite that as 1 minus w. It flip-flops them. So if ever you have it close like this, you can multiply it or factor out that negative 1, and it's going to make it the opposite way. So now we do have 1 minus w, and I can cancel both of those. So we're just left with negative 1 over z. And that's how that simplifies. That's your final answer. It's as far as we can take it. Let's take a look at the next one. xy minus 3x all over 3x squared minus x squared y. Well, what does this have in common? Between xy and 3x, there's an x in both of them. So we're left with y minus 3. All over, what does 3x squared and x squared y have in common? X squared. So then we're left with 3 minus y. Again, the x and the x squared will cancel, so we're left with an extra x in the denominator. Now I'm close here again. We have y minus 3 and 3 minus y. So I'm going to factor out that negative 1 and make the top 3 minus y. And then it matches what's in the denominator, so I can cancel them. Then we're left with a negative 1 over x. And then that would be our final answer. So that's how we simplify rational expressions. Alright, here are some notes on multiplying and dividing rational expressions. Recall that when we multiply fractions, so I'm just going to refer to these as fractions. When we multiply fractions, we multiply straight across. So when we have a over b times c over d, we get a times c over b times d. You just multiply straight across. Same thing. So that's going to be the same thing when we're multiplying these fractions. We're just going to multiply whatever's on the top by whatever's in the denominator. Then we also, when we divide, we multiply by its reciprocal. So notice we have a over b divided by c over d. You multiply by the reciprocal, so it's a over b times d over c. And then it's ad over bc. We're also going to be doing that. So let's take a look at just these. So there's no factoring involved yet, but we're going to multiply these. So 4a over 5b times 15b squared over 16a cubed. When we multiply fractions, I can cross-reduce. So whatever's on the bottom can divide with whatever's on either of the tops. And same thing over here. I cannot go this way, and I cannot go up here. It has to be one from the top and one from the bottom. So this a will cancel with this and leave us with a squared. This b will cancel with this and leave us with just 1b. Now 5 and 15 can reduce. Divide them both by 5, and I get 3. 16 and 4 will reduce, so I'm left with just a 4. So what do I have left on top? I have 3b left over, what's down here? 4a squared. There's nothing left. 3 and 4 cannot reduce. B and a are two different things, so this is as simplified as we can get. So that cross-reducing is going to really help you. So we're not multiplying 4 times 15 and then 5 times 16 and then trying to reduce it. Do all of the reducing beforehand. When we divide, you must flip the fraction before you cross-reduce. So I have to rewrite this as 4x squared y over 15 a cubed b cubed multiplied by the reciprocal. So it's going to be 5ab cubed over 2xy squared. Now I can cross-reduce. So now the 15 and the 5, so I'm left with a 3 down here. The 4 and the 2, so I have a 2 up here and a 1 down here. Again, the x's, so that'll leave me with 1x on top. The y's, so I'm left with a y on the bottom. The a's, so I'm left with an a squared on the denominator. And the b's are both cubed, so they're just gone. They both cancel out together. So what's left up here? We have a 2 and an x. So we have 2x in the numerator. I have 3 a squared y in the denominator. So you want to be careful to make sure you get all of your pieces that are left, because it's easy to forget some of these if you're not paying a close enough attention. So that's why I kind of rewrite them down a little bit or up, so it's easier to see what you have left in each piece. So we're increasing the difficulties just a little bit more. I cannot emphasize enough with this particular example, or with examples like this. I cannot repeat and say enough. You cannot cancel when it's a polynomial like this. I cannot say x squared over x squared and get rid of them. You cannot do that. You must factor first. So somewhere in your paper, please write must factor first. It's the only way this works properly is if you factor first. Doesn't matter where they are, factor everything. X squared plus 2x minus 8 is going to factor into x plus 4 and x minus 2. And I'm not going to spend a lot of time on the factoring. If you're still struggling with factoring, come see me. We can spend some extra time with it. I'm not going to go through that whole thing. We've spent chapters on it. We've been tested on it, so you should know that by now. So now we have over here x plus 4 and x plus 1. So that's factored. Multiplied by 3 times x plus 1 all over x minus 2. Now I can cross-reduce just like I did, but with whole phrases. So this x plus 4 and this x plus 4 will cancel. This x plus 1 and this x plus 1. This x minus 2 and this x minus 2. So what am I left with? Just a 3. When we multiply those, everything cancels except the 3. Let's take a look over here. A plus 2 and a plus 3, those cannot factor anymore. So those are already factored. I'm going to put them in parentheses just so we know those are grouped. Multiplied by, flip the fraction, a squared minus 9 over a squared plus a minus 12. Now remember, this piece here, we need to factor it. So we're going to have a plus 2 over a plus 3 times a minus 3 times a plus 3. And then a squared plus a minus 12 is going to factor into a plus 4 and a minus 3. So what can we cross-reduce? The a plus 3 down here with the a plus 3 over here. The a minus 3 and the a minus 3. So we're left with a plus 2 all over a plus 4. I cannot reduce these. They're added. I cannot say a over a is 1, 2 over 4 is 1/2. It doesn't work that way. You cannot do anything else. That is your final answer, is that one right there. So the last thing we need to talk about is what happens when we have fractions within fractions. If you recall, now again, I'm asking you to do a lot of recalling. This is all going back to fraction work, which I know a lot of you hate, but you're going to have to get used to it because this whole chapter is all about fractions. So if you recall, fractions are really just a way of saying you're dividing. So a over 5 over 3b means you're taking a over 5, a fifth, and dividing it by 3b. Same thing over here. You're taking m squared minus 9 over 8 and dividing it by 3 minus m over 12. So just rewrite it as a division problem. And then you have fractions that are being divided. And that's all that's to it. So if we look at this very last example, all I'm saying here is I'm taking this fraction and dividing it by this fraction. So if we rewrite that as such, I'm not going to factor anything yet. And I rewrite that as divided by r over 5s minus r. Now this is exactly what we just did. You multiply by the reciprocal. So we have r squared over r squared minus 25s squared times 5s minus r all over r. Now we can cross-reduce. But I can't do that until I factor. So now we have r squared over r minus 5s times r plus 5s times 5s minus r all over r. So the r squared and the r will cancel, leaves me with one r here and nothing down here. Notice, r minus 5s, 5s minus r. What can I do to rewrite that? I can rewrite this one as negative 1 times r minus 5s. Now we have the same thing. So now these will cancel. We're left with an r and a negative 1, so we have negative r over r plus 5s. I cannot reduce these because this is being added to. This is my final answer. So complex fractions are going to be easiest if you just rewrite them as the division of two separate fractions. So your homework to be done in class is 17 through 33, the odds. So please make sure you have everything with you to do that. Both books, notebooks, everything else. And we will be doing this in class.